Hi again, everyone. Welcome back to part 2 of this two-part series on building the ultimate MainStage live performing keyboard rig. Let's have a look. In part 1, I stated my case for wanting to use virtual instruments. They sound better than most available hardware synths and keyboards. Given that preference, I needed a software host platform to deliver it. I chose Apple MainStage back when it was first released in 2007, as I feel it was and still is the best software of its kind available. But to avoid the potential physical dangers of having a laptop up around me on stage, I wanted to build a headless system based around a Mac Mini. They also have the added benefit of being way more cost effective than any laptop with a similar amount of power. To do that, I needed a hardware controller that is capable of receiving MIDI messages back from MainStage, updating the controller, so that on stage I can see the value of each knob on a patch-by-patch basis. It also needed the ability to receive remote text messages from the Mac, so I actually know what each knob is assigned to in each patch, because they might not be the same from patch to patch. As mentioned in part 1, the only controller I'm aware of that will receive MIDI feedback to update control positions on the hardware and has the ability to receive remote text messages from the Mac as well to its LCD is the Novation SL series. Novation's virtual MIDI port that communicates feedback to the controller is only accessible via their own AutoMap software and is hidden from the rest of the computer. So this forces you to work in a less than ideal way to take advantage of its feedback capabilities. I see from internet forums that many users have just given up using AutoMap when working with MainStage, and I almost did as well until I worked out a way to tame it. So let's have a look at the software setup to make it work. In general terms, the MIDI signal flow works like this. I hit the button on my controller which sends a MIDI message to the computer. That message hits AutoMap and passes through AutoMap unchanged to then be received by MainStage that is pre-assigned to change patches upon receiving that certain MIDI message. MainStage changes patches, and because I've mapped every hardware control on the Novation to a screen control in MainStage, I have the layout set up so it sends out all of the screen controller MIDI values for the newly selected patch back to AutoMap, which then passes all of those messages through the feedback hidden port to the Novation controller, and all of the knobs, buttons and faders quickly update their values to reflect the settings of the newly selected patch. The only thing that doesn't get sent to the controller by MainStage are the text labels to be displayed on the Novation LCD screen. The text labels are provided by AutoMap. In AutoMap, each page of the user section of the AutoMap setup represents one single patch within MainStage. Page 1 of AutoMap represents the text labels for patch 1 in MainStage. Page 2 is the labels for MainStage patch 2, and so on. So every time I send a patch change message from my controller, MainStage responds by changing patches. The hard bit was figuring out how, with just one button press on the controller, how could I get the same MIDI message to also change the AutoMap page and update the text labels on the controller LCD. To understand this, we need to know a little more about how AutoMap and the SL Mark II talk to each other. As I've already mentioned, the MIDI feedback port of the SL keyboards is the only way to get the controller to respond to MIDI messages. Novation call it the AutoMap port. They hide that port away and don't allow end users to send messages to that port directly. The only way is to send MIDI messages to the AutoMap software and then have the software pass the message to the controller through the hidden virtual MIDI port. Once you get your head around that, it's not a huge problem, as you still need AutoMap anyway, just to be able to write text to the controller screen. All of that aside, AutoMap uses mostly plain standard MIDI messages to communicate with the controller, and just a few MIDI sysx strings to do things like write text to the LCD and also to get the controller to jump from dumb MIDI mode into AutoMap mode. If it were possible to access the AutoMap virtual MIDI port, it might be possible to bypass the AutoMap software and write your own sysx, but it's not, and that's just too darn complicated a solution anyway. So my first light bulb moment upon reading the documentation that Novation supplied me was that the controller was actually sending a MIDI message to AutoMap to change the pages within AutoMap using the P1 and P2 up and down buttons alongside the LCD. The documentation also had me discover that the the P1 up button sent MIDI controller 89 value 127, and the P1 down button sent MIDI controller 88 with a value of 127. It got me thinking that if I could get those messages into the automap port, then the same button that changes MainStage patch could also change automap pages. Sadly, there's no hacking into the automap virtual MIDI port. How many times have I said that? But even though Novation warn against it, you can actually edit the onboard automap template assignments. So here's what I did. In the automap template, I edited the rewind and fast forward buttons on the controller to make them send controllers 88 and 89 as mentioned earlier. You can use any two buttons you like on the controller. I just use them because I don't use them when I'm performing. Once I had done that, then those two buttons changed the automap page up and down. But there was no way of passing a usable MIDI message from that single button push onto MainStage to get it to change patches. The final piece in the puzzle was realizing that in the automap template on the controller, you can also assign more than one MIDI port for a given message triggered by a button push. So on the controller, if you look at the port assignments, U3 represents USB 3, which is the hidden automap port. And the only other port options you get in automap template mode is to send to either of the 5-pin MIDI ports, port 1 and port 2. So in addition to sending to the automap port, I also assign those controller 88 and 89 messages to send to port 2 of the 5-pin MIDI, and I use a short MIDI cable to loop that message back to the MIDI in of port 1 on the controller. Now port 1 passes unaffected into MainStage. So therefore, I can get the same message to go to the automap software to change text pages while sending the same message to change patches in MainStage. Is the system perfect? No. It is possible to get the automap page number out of sync with the MainStage patch, which will mean the text labels might not reflect the actual assignments in MainStage. Another limitation is that you can only increment up or down one patch at a time. There's no jumping to an entirely different patch number that's not sequential. Also, for every patch you create in MainStage, you have to go into Automap and create a new page and update all the text labels for the controls used in that patch. And there's no copy or paste from page to page within Automap, which I can only see as an oversight on Novation's part. It is possible to edit the Automap template file using something like OS X text edit program, because that file is only simple XML. I actually do this quite a bit and it's pretty straightforward, and it's quicker than having to retype every name into every knob of every controller on every page of your automap setup. Because let's face it, most of the time the same knobs will do the same things in each patch, because you'll want things like master volume and effects return levels on a concert level and other things like that. You won't want to reassign them from patch to patch. You can actually make concert level assignments, and you only reassign, synth voice controls that you want to surf with in a performance from patch to patch. You might have also noticed that in the video that when I change patches on the controller, not only does the text and knobs update, but the iPad jumps to a different chart as well. This is achieved using the excellent free iPad and OS X app called Music.io, just the MIDI part of it that's free. It allows for bidirectional MIDI comms over the standard Lightning cable. My chart reader is an iPad app called Fourscore. It will happily change patches upon receiving a MIDI program change. Back in MainStage, it's easy to add a single external channel strip to each patch and have it send a specific program change to the iPad to change charts, and it's fully locked and synchronized. It can't get out of sync because the same MainStage patch is sending that message. I wished I could also lock the automap page to a patch level command in MainStage like I do with the iPad, but with no way to send MIDI into the automap virtual MIDI port, this does not seem possible. Novation have made a great controller here. It's a wonderful feeling unweighted keybed, and it has unique features that make what I want to do possible. And the particular combination of features that it has is not available in any other controller as far as I know. I'm sharing my ideas and discoveries here for a couple of reasons. One is I hope it might help others, but also I hope that Novation might get that there are people out there using their technology in ways they might not have considered, and that it might motivate them to do a software update in their automap software and or the Remote SL's firmware to implement some of these requested features. To be honest, all I would really like to see is the ability to copy-paste pages of assignments in the automap setup, and the big one, allowing users to access the AutoMap virtual MIDI port so they can feed their own MIDI messages into the AutoMap system as desired. I hope this has helped some of you. Feel free to hit me up with comments and questions. Catch you later.